Now, I want to talk CV. Okay. This is important. Okay, that's a typical CV capacitance versus voltage, right? Inversion, depletion, and accumulation, all three regions. Now, let's run this guy. Go to analyze. Let's run this guy. Let's see what happens.
So what are the settings used for the?
It was just the default.
It's the default. Something doesn't look right though. Something's not right. What's not right here? Something is not right. Let's go back. We got CV high. Oh, we got CV high on the gate. CV high on the gate. CV high is which one?
Are you missing? You're missing the CV low, aren't you? You have one CV low and you have two none.
Oh yeah, that's not right. This should be.
You need a CV low.
Oh, it doesn't matter because it's shorted up there.
Oh, okay. So it still doesn't matter.
The problem is I'm connected to the bulk and I don't have a cable for the bulk.
Okay.
So let's just move this cable. Let's see if that works. Oh, it's not going to short though because I don't have. But it shouldn't matter. I might need a fourth cable.
Or can you short them in the software? Would that fix it?
It should be doing that, but why is it not working? Gate, drain.
Gate is high.
Something's not working right here. Gate. Oh, I don't have anything in the gate. Duh. This is the gate. Yeah, I moved the wrong cable. So I should be moving. Which way? I should move. Let's move the source over. I moved the wrong cable. Let's try that. So I disconnected the gate. We need the gate. Something doesn't look right. No, that's not right. Something's not right here. Maybe I need that fourth cable. That might be the problem. Let's see. And are these connected right? I got one is the source. One is the source. Two is the drain. Yeah. Three is the gate. And four is open. Give me another cable.
Do we have to do the compensation again?
Yes.
If we are using the.
You have to make a new cable.
No, we shouldn't. We shouldn't have.
Oh, even if
because
you're adding a new
they're
cable?
Let me see. Do we have to? Yeah, we will. Yeah, we'll do it. We'll do it. Okay, so
You got it.
okay. So first thing I'm gonna do then is I'm gonna go back to the CVIV configure, and I'm gonna go to configure, and I'm gonna make channel 4 CV low. Channel 4 is
Open right.
my bulk, so we're gonna call that bulk. Oops.
You're good.
Bulk. Okay, so that's my bulk. And let's run that. So I got CV low, CV low, CV low, CV high. Okay, now let's go
hit
back.
run? Or
Yes.
It ran the configure.
Take this out as you're open. Okay.
Closer.
I actually like doing the CV without that, to be honest with you. It's convenient.
If I were to do it without, how would I do that?
You could run your red cables directly to this fixture. See these?
Oh, okay. So instead of
But you need a T.
But then, I mean, we don't have the fixture, right? Then,
You don't have the fixture.
no, our fixture would be the box.
Our fixture would be the box.
The
So you have,
enclosure.
Okay.
yeah, so you should have, that came with your system, you should have adapters to convert the SMAs to triads so they can go to your probe.
Mhm.
So, or you can get probes that are SMA. So there's lots of ways you can do it. Okay, so open compensation successful. Okay, exit. Go back to this. This is none, that should be good. CV low, CV high. I'm not gonna select that. Let's run that. See what, oh, I don't have the device in. Stop. Do that all the time. Device in. Fine. There we go. I think that's better. Well, maybe not. That doesn't look right. Something's not working right here. Huh. What am I missing here? Missing something here. CV high is on the gate.
Like low frequency, high frequency, did you set that frequency or?
Yes, I did.
You said there wouldn't be a need in the configure to set those up, like they were on none. You said that should be
it's
okay.
defaulted.
Okay.
The frequency is single frequency. You can do a sweep if you want
Sure.
as well.
I was saying for the drain and the source, you don't have to set. I know you shorted it on there. You
No,
don't.
I don't think you. I think you just leave those as none. I think that's the way it should work. I could try it, but I
Yeah,
don't think it
I'm not
matters.
sure.
CV low. Yeah, so you cannot use
Oh,
more
okay.
than once. Yeah, so you just leave that as none
Gotcha.
since you got it done there.
Sure.
Why is it not working though? I got them connected correct? I guess that's the first question. This is H curve. H curve. H pot.
I'll just
I don't have SMU4 though.
Just use.
What's that?
I don't have SMU4, so what I need is one of these cables.
You can just leave the microphone ready. Doesn't matter in here. So darker.
I don't think that should matter, but maybe it does. Huh, it's not working. Why is it not working? Why is it not working? I think I did that right.
Gate, drain.
Let's see. CV low, CV low, CV.
Okay.
Channel 3 is the gate, which we all have. Why isn't this working? 2-wire. Or 4-wire. This should work. 4 is the bulk. Okay, let's try this device.
Change
Why
device.
that's, I don't know why that's not working. No,
Configuration.
something is not right.
Can we do a simpler measurement like
It doesn't get much simpler.
an AC? Can we visualize the AC sweep?
No. What is the problem here? Ow. Channel 1? Who's this guy? It's gotta be right, because it worked on the DC stuff. Channel 2? Who's this guy? Yep, channel 3 is yellow. Channel 4 is a feed through. I'm confused. doesn't that work?
When it is giving with both transistor, right?
Mm-hmm.
You are sweeping from -5 to 5, right? -5 to 5. What frequency you are measuring?
Megahertz.
Megahertz. Okay, that's high frequency.
This is noise. Huh. Now I'm confused. What is the problem here?
For the CV, okay, for the CV measurement, voltage need, that is the DC voltage, right?
There's a DC bias and there's an AC.
DC bias converted to AC. The DC bias convert into AC, right?
Yeah, see, this is reading picofarads, and the confidence check is reading femtofarads, so that's not good. Why not?
Megahertz.
Oh, DC ground. You don't want DC ground. Why is it DC ground? Oh. Is that, oh, that's all we get there. Oh. Yeah, okay, that's right. It's got me confused. Something doesn't seem right here. 2-wire CV IV test. CV high, CV low, low, low. Wonder if there's a problem with that guy.
What are these terminal segments?
This should work. There's something wrong.
Speed delay 0.1 seconds.
Well-
Hold. It's supposed to be 0 seconds for the whole time?
Yeah. One thing we could do, we could try it without this and see if it works.
Okay.
We need adapters for that. So you should have gotten adapters for this. The problem is we probably can't find it, right? SMA to
Yeah.
to BNC, and then you need BNC. We're not going to have all this stuff. There's no way. There's one adapter I see.
This one?
Yeah, that's one of them. No, that's not. This is it. This is one. We need two of those.
What adapter you need? SMA to?
Estimated BNC. There's one here. And then we need these, now this is BNC to triax, and then we need estimated BNC. Oh wait, now it's measuring. Oh. Now it's making sense. What's going on there? Huh.
What did you do?
I don't know.
Move the cables.
I breathed on it. Now it's working. Okay. Okay, but now let me show you something here. that finish.
And
Get
it's
rid
not
of
like
this.
that this was not perfectly.
Yeah, this was loose, I think, is what it was. I tightened it. But, okay, so I didn't add the compensation. So this is a bogus measurement.
Mm.
And I can show you that because it's probably going to have more capacitance than it really is. And by adding the compensation now, I can take that out. So I go over here and I'll go eliminate the open compensation and watch what happens. And I'll run this again. And you're going to get
What is the
something.
open compensation? Eliminate the open compensation.
No, I added the open compensation. I added it.
Oh,
I first ran it without the compensation. So that means
I see.
you should have higher value. But now watch this. If I compare, oh, now why did it not work? Really? What happened? I don't. The
Yeah.
last test doesn't. The last test worked. Oh, there it is. Why isn't it comparing
It's
it?
just two minus 12.
Are they that far off?
Yeah, they're too far off. Maybe you can just scale the
Should be able to auto scale it. Why isn't that
Yeah,
work?
they're just too
That's
far
weird.
off, I think.
No, they're not.
They're very much close to each other.
They're
No,
the
you just have to
same.
rescale the y-axis.
The auto scale should work with that. That's what I don't understand.
Because right now it's 55. The other one is like,
I don't.
14.
That's a bug. I think that's not right.
mm,
That's a bug. That should auto scale. It's showing it as a flat line.
yeah.
It's not a flat line.
No, I mean, you do
Yeah.
have that. It's just that the scale has to be.
Oh, the scale's way wrong.
Yeah.
What the heck is that all about? Okay, here's what we're gonna do. We're gonna start over. That's just not right. You're gonna wait a couple seconds before you run it again. Okay, let's go to CV config. Let's run that to get that set up. Boom, boom, boom. CV MOSFET. Let's run that. See what happens there.
So you're running one without the compensation?
What the heck is going on here? It's not scaling it right.
Yeah, it's not scaling.
It's not scaling right. Why is it not scaling right?
Yeah, they're way off.
It's way off. It's right if I do
Because
just do one.
it's changing between
Yeah, I know.
55.3 to 50.5.9. So it's a very,
It's very small.
very small. Yeah.
It should show me. That's just not. That's something wrong there. That's just.
Can you normalize it somehow? Or,
I don't
well,
know.
it doesn't make sense to have normalize
Doesn't
it.
make sense. What if I do it this way? There it is.
What you doing?
That's a bug. But wait, they're the same though. Oh,
Yeah.
because they were the same. One of them was different. Let's take that one and that one. No. What the heck is going on here? I don't know which test was which anymore.
Yeah, I think that's
This
it.
was the same with
Yeah.
the compensation. Then we had one with the compensation off, which should be this one. Let's just try running it again. Let's run it again. Let's turn off the compensation.
Mhm.
So compensation means like it's some parasitic effect.
Yeah.
And that's without compensation?
Yes.
4.2, okay. 10 minus 12.
Wow. Showing you the difference
See, this is 4.
between the two.
Yeah,
Yeah.
this is almost 10 orders of
Yeah. Okay.
magnitude.
So that's how much the compensation
Yeah.
has an effect on it.
That's
But
a huge.
Yeah, but wow, it's so, the scale is so weird, you're not seeing the,
Yeah,
you're not seeing the whole picture here. Unless we do that.
because that is like 55 without, and then with compensation.
That doesn't seem, let's see. Okay, the original one has got more capacitance. Okay, it's about the same scale, but I guess there's so far out, there's so much capacitance here that it's throwing off the graph.
Yeah.
That's what it is.
Wow,
That's a lot. That's a big difference between that and that. 55.9 and 5.2. Wow.
Yeah.
So there's a lot of capacitance. Most of it's probably coming from this guy. That's my guess. So if you take that out, you can get rid of that capacitance, but the compensation gets rid of it. So you shouldn't have to
Yeah.
worry about that.